Okay, I'm going to go through the study guide for the energy unit. So hang on, let me get situated a little better here so that I can write and y'all can see. Okay, so I'm going to go through, 5 or so questions per video. So let's start with definitions. How is potential energy defined? Okay, so we've talked about in our course, we're using gravitational potential energy. And that is our energy of position above the earth. So we've got a height, and the force of gravity is going to act on us. So until that happens, we've got this energy that is like a stored energy that's waiting to turn into another form of energy. Okay, so gravitational energy of position or a stored energy. And the equation that we use for this energy is potential energy equals mass times G. That's our same 9.8 meters per second, times H, where H is our height. Then we have kinetic energy. This is our energy of motion. So this is for an object that is moving. You have got to be moving to have kinetic energy. Potential's like the energy that's waiting to happen, and the kinetic is happening if you're moving. Our equation for kinetic energy is Ke equals 1/2 times mass times velocity squared. Remember, squaring that velocity, that is important. Okay. Total mechanical energy is our total energy of our system. Okay, so this is the sum of all energies of an object or a system if we have more than one object. Okay, and mechanical energy is the sum of kinetic plus potential. Mechanical is our energy that's conserved. Okay, so that total is always going to stay the same. These two totals will change depending on your scenario, your height, your motion. This total always stays the same. Okay, so that leads us into our next question. What does the conservation of energy mean? Okay, that means that energy is not created or destroyed. It's just transformed. So it turns into other forms of energy, but our total energy stays the same. It does not get, we don't add more, we don't take away, we just change based on where we're at, how we're moving. It transforms into different forms. So describe what happens to the mechanical energy of a book falling from a high shelf. So let's say we've got a shelf in our room. We've got a book on that shelf and it's going to fall. So at the top of the shelf, when it's sitting there, it has all potential energy. It's got that energy of position. It's not moving yet. It's at a height above the earth. So the energy is stored, like waiting to transform. Then at the bottom, right before the book hits the ground, all of our energy is kinetic. We don't have any height. We are moving. We're not going to think about when it hits the ground. We're thinking about right before it hits the ground. We're moving there, so all our energy is kinetic. In between, we have both. And the values depend on our height that we're at, and they depend on how fast we're moving, but we're going to have a mix in between because we've got height, but we've also got movement. In terms of total energy, it's the same at all points. So whether the book's at the top shelf, sitting here waiting to fall, whether it's in the midst of falling, or whether it's right before it hits the ground, the total energy is going to be the same. It is not going to change. Okay. If I throw a ball into the air and it gains 20 joules of potential energy as it travels upwards, how many joules of kinetic energy did it lose? So the energy is going to shift as the object's moving. So it's going to lose the same amount of kinetic energy as it gained in potential. So if it gained 20 because it's gaining height, it's actually slowing down as it travels upwards. So it's going to be losing kinetic energy. What must be true of the total energy of the ball? It stays the same. So mechanical energy or total energy always equals kinetic plus potential. If in the case of this throwing the ball in the air, if potential is going up, kinetic has to be going down to keep that total at the same value. Okay. All right. Here we've got a roller coaster. So we've got some different points. We want to rank these from greatest to least. Okay. So we're going to start with potential energy. Potential, remember, M times G times H. That's our energy of position. So our potential is going to be the highest where we have the most height. That's going to be point A. Okay. Then our next highest point looks like C. So A is going to be greater than C. Then E is next. And then, I don't know, I kind of feel like B and D look like they're about the same height to me. So I'm going to call those equal. Okay. So we've got our greatest potential energy at A. Then our next is at this height of C. E is below that. And then B and D are the lowest heights. When we think about kinetic, because we're shifting between potential and kinetic, okay, it is going to be the opposite. My highest values of kinetic energy are going to be these two bottom points because that's where I have the least amount of height. So I'm going to have the greatest kinetic energy there. And then it's going to be the reverse order, basically, of what we did for potential energy. So those are going to be greater than E, and then E is going to be greater than C, and then A has the lowest amount of kinetic energy because it's got the most height. Also, it's got the highest potential energy, so it's going to have the lowest kinetic because these two are going to shift back and forth. My total mechanical energy is the same at all points. So A equals B equals C equals D equals E. All of those have the same total mechanical energy. There's just a shift between the mix of that, of potential and kinetic. All right, I think I'm going to do one more question in this video. So I've got a frisbee flying through the air. It is at a height of 2 meters off the ground and a speed of 4 meters per second. So what types of energy does it have? Well, it is at a height of 2 meters, so it's going to have some potential energy. It's also traveling at a certain speed, so it's going to have kinetic. And then it's got both of these. These are always going to add up to mechanical, so it's got that as well. So it's got all types, okay? If I want my total energy, my mechanical energy, I'm going to do PE plus KE. And in the case of this problem, using the givens that I have, I'm just going to use my two equations. So I'm going to have mgh plus 1/2 mv squared. That's going to give me potential. That's going to give me kinetic. So let's see. The mass is 0.5. I'm going to multiply that by 9.8 and then multiply that by my height of 2. That's my potential energy, plus 1/2 times 0.5 times 4 squared is my velocity. I got to square that. And then I'm going to calculate all this out. So I have 0.5 times, got to turn my calculator on, 0.5 times 9.8 times 2 gives me 9.8. 0.5, which is the same as 1/2, times 0.5 for my mass, times 4 squared for my velocity gives me 4. So I have 4 plus 9.8, and that gives me 13.8 joules. That is my total energy of my Frisbee because it's got both potential and kinetic in it. And so I got to add those two up. Okay, more in the next video.